So in this video, I'm going to use the critical value approach to solve the problem that was previously completed with the p-value approach. So here we're doing the critical value one. So again, with the first step, it's the same as what we did with p-values. We need to write out the null hypothesis and the alternative hypothesis. So HO, that's the null one. So this is the hypothesis of no change or no difference. So what we're going to say here is that the population has a mean of 100, okay? No change. H1, this is the alternative, so what we're kind of trying to test. So since we're interested in if the class has above average intelligence, we're going to be looking at whether the mean is greater than 100 as the alternative. Alright, so the next thing that we need to do is figure out our criteria for the decision we're going to make. So what is going to constitute us accepting the null hypothesis and what's going to constitute us rejecting it. So this time alpha is 5%, but what we're going to be looking at is if the z value that's critical, which we're going to be able to get based off this 5%, is larger than the calculated z value for our point of interest, which relates to this 106 sample mean. If that is true, then what we're going to do is accept HO. And then the opposite is if the critical z value, again, which we're going to get from this 5% level of significance, is less than the calculated z value for relating to our sample mean. If this one's true, then we're going to reject HO. Now, I've put these bars around our values. All that's doing is saying we take the absolute value, so the positive value. So if we end up with a negative z value, all we do is say, okay, if it was -3, with the bars around it, we're going to take it as +3. Same thing for these ones here. Alright, so now we're up to the part where we actually need to do our calculations, and we need to figure out this critical z value and the calculated z value to compare. So let's start by drawing out our distribution of x bar. So we know it is normally distributed, and from the previous video we already said that mu x bar was equal to 100 and the standard deviation of x bar was equal to 2.5. So marking that on the diagram, we've got 100 here, and I'll just pop this out to the side of 2.5. So go back and see the previous video if you want to know where they came from. Alright, so what we were interested in was when we had a sample mean of 106.625. So let's pop that on here. Alright, so what we want to do is convert this into a z value, and this becomes z calc. Okay, so again we have our equation for doing that. Just looks like this. And we saw in the previous video that when we substitute our numbers in, this works out to be 2.65. So that is our z calc value. So when we convert the mean into a z value, we know that that goes to 0. So the only other thing we need to figure out now is the critical z value. So let's just mark a point here. We don't really know where this sits yet along the axis, but this is going to be z critical. So what we do know is that this critical z value relates to our alpha value of 5%. Okay, so what we're looking at is if we drop a line here and look at the z critical value, or even worse or more extreme, what we know is that the area that's included in here is equal to our alpha value. So in percentage form it's 5%, or in a decimal it's 0.05. So based on this information, we should be able to go and look up what value is critical when we have an area of 0.05. And of course that's going to come from our inverse normal table. So let's go and have a look at that. So I've got that here. So we've got in this section here, 0.05. So if we look down, this is 0.05. So we can see that it's equivalent to a z-score of 1.6449. Alright, so now we can kind of get to the point where we compare our critical and our calculated z values in order to determine whether we're going to accept or reject HO. And looking at this, what we can see is that, okay, we've got z critical of this value here, so we know that the probability of this occurring, or even more extreme, is about 5%, or is 5%, okay? But from this point here, if we looked at the area from it and the more extreme side, it's going to be much less. So there's a very, very, very small chance of this happening, which is less than 5%, and that's what we're interested in. So let's write this out. So our z critical is going to be less than the calculated value. So remember, the bars just mean take the positive. So since this already is positive, it's just going to be 1.6449, sorry, is less than 2.65. Okay, so that's this one here. So that means that we're going to reject our null hypothesis. So again, what we're saying is that we have sufficient evidence to say the class is above average IQ or intelligence. Put IQ. So that's pretty much all there is in terms of this video. We have achieved the same end outcome as what we did with the p-value approach. They are equivalent to each other. It's just whether you look at, I guess, which direction you look at it. So whether you calculate out your areas or whether you calculate out the critical z value, it's exactly the same thing in the end. So that's all there is for this video, and I'll see you in another one.